Welcome to Course 3 on Industrial Processing, Module 1, Fundamentals of Food Composition and Chemistry. Today, I'm going to talk about food additives and functional ingredients, two critical elements in modern food processing and preservation. We will explore what these substances are, why they matter, how they work during food processing, and the emerging innovations transforming the industry. By the end of this session, you'll have a clear understanding of how these ingredients keep our food safe, fresh, and nutritious while meeting consumer expectations and regulatory requirements. This module introduces the fundamental principles of food composition and chemistry. Understanding these concepts will prepare you to evaluate and optimize processes throughout the food value chain, from production to consumption. We'll examine the significance of each food component, including its structure, function, and contribution not only to human nutrition, but also to the sustainability of our food systems. After completion, learners will be able to explain the roles of food additives and functional ingredients in food processing and preservation. Let's start with definitions. Food additives are substances we deliberately add to food for specific purposes, to keep it safe, extend shelf life, improve taste, enhance texture, or make it look more appealing. These are all rigorously evaluated for safety by international regulatory bodies before they're approved. Functional ingredients are slightly different. They're components that do more than just preserve, they actively contribute to health and nutrition. Think of dietary fibers that support digestive health, or probiotics that improve gut microbiota. Both additives and functional ingredients are essential in modern food manufacturing, allowing us to meet consumer demands for safety, quality, and wellness. Food additives aren't new. Humanity has been preserving food for millennia using simple, natural substances: salt for curing, sugar for jams, vinegar for pickling, and smoke for meats. When industrialization arrived, manufacturers discovered that chemically purified and synthetic additives could expand the possibilities dramatically, enabling better control, longer shelf lives, and new product innovations. Today, we're in an exciting phase where biotechnology allows us to produce novel functional ingredients with targeted properties, and we're increasingly sourcing additives from natural extracts derived sustainably from food waste. It's a blend of ancient wisdom and cutting-edge science. Safety is paramount. International bodies like the Codex Alimentarius establish global standards. The EFSA in Europe and the FDA in the United States conduct rigorous assessments of additives before they're permitted in food. These frameworks require manufacturers to use additives only within prescribed limits, ensure transparent labeling so consumers know exactly what's in their food, and periodically reevaluate previously approved substances as new scientific evidence emerges. For example, titanium dioxide, a white pigment used for decades, was recently questioned in the EU as new toxicology data became available. This system balances innovation with consumer protection. Manufacturers comply with maximum permitted levels, and regulators maintain transparency. It's a trust-building mechanism that keeps food safe while enabling the industry to innovate responsibly. Let's explore the main categories of food additives. Sweeteners replace or supplement sugar, allowing manufacturers to create lower-calorie products. Colorants restore or enhance color. This is especially important in processed foods, where color can fade during manufacturing or storage. Natural extracts like anthocyanins from berries are increasingly preferred over synthetic options. Preservatives are perhaps the most critical category. They extend shelf life by inhibiting the growth of spoilage microorganisms and pathogens. Sorbates and benzoates are common examples used in acidic foods like juices and dressings. Antioxidants prevent oxidation, the chemical process that makes fats rancid and degrades colors. Tocopherols and ascorbic acid are particularly valuable because they're also nutrients, providing dual benefits to the food. Emulsifiers and stabilizers are fascinating. They solve a fundamental problem in food chemistry. How do you keep oil and water mixed when they naturally repel each other? Lecithin, derived from soy or sunflower, has a molecular structure that bridges oil and water, creating stable emulsions found in mayonnaise, salad dressings, and many processed foods. Texture modifiers include thickeners like xanthan gum, which increase viscosity to achieve the right mouthfeel, and gelling agents like agar or carrageenan that create the desired firmness in desserts and meat products. Carriers are less visible but equally important. They're the vehicles that help us distribute other additives evenly throughout a product. And acidity regulators are essential because many preservatives only work effectively at specific pH levels. Citric acid, for instance, acidifies foods and simultaneously enhances the antimicrobial activity of sorbates. We have additional categories that address specific processing challenges. Flavor enhancers intensify the natural taste and aroma of foods. Monosodium glutamate, or MSG, is the most famous, though there's ongoing discussion about its use. Anti-caking agents are crucial in powdered products like salt or spices. They prevent the particles from clumping together, especially in humid environments. Humectants like glycerol are used in confectionery and baked goods to retain moisture and maintain softness. Chemical raising agents create the bubbles in cakes and bread by releasing gas during baking. And sequestrants are chemists' tools. They bind metal ions that could otherwise cause discoloration or off flavors. Each of these categories addresses real challenges manufacturers face in maintaining product quality from production through distribution to the consumer's table. Functional ingredients represent a shift in how we think about food, from merely safe and shelf-stable to actively promoting health. Dietary fibers are fundamental. They're extracted from cereals, fruits, and byproducts, and they support digestive health while helping regulate cholesterol and blood sugar. Some fibers, like inulin, are prebiotics. They feed the beneficial bacteria already living in our gut. Probiotics take this further. They introduce live beneficial microbes directly. When properly protected during processing and storage, probiotics can significantly enhance digestive health and immunity. Phytochemicals, compounds naturally present in plants, have powerful antioxidant and anti-inflammatory properties. Plant sterols are particularly exciting for cardiovascular health. They actively block cholesterol absorption in the intestine, providing a measurable health benefit when consumed regularly. These ingredients represent the convergence of food science and nutritional medicine. Food as functional medicine. Now let's talk about the real challenges food processors face. Thermal processing, heating, pasteurization, sterilization is essential for safety, but it's tough on additives. Ascorbic acid, that valuable antioxidant, degrades rapidly during canning. Natural colorants like anthocyanins fade. Protein-based functional ingredients are equally vulnerable. When you heat milk products, the proteins denature, changing their ability to foam, gel, or emulsify. In bakery products, egg proteins behave differently after baking. Manufacturers have developed solutions. Microencapsulation wraps sensitive additives in protective matrices, protective shells that hold up during processing and then release the active ingredient where it's needed. And food scientists select heat-resistant analogs, different forms of additives that withstand higher temperatures while maintaining efficacy. Mechanical processing is equally important. When you homogenize or mix at high speed, you're applying tremendous shearing forces. This can actually help emulsifiers do their job, breaking oil into smaller droplets, but excessive shearing can cause previously stable emulsions to break down. Particle size matters tremendously. When you mill antioxidants finely, they disperse more evenly throughout the product, providing better protection. It's not just about adding the ingredient, it's about engineering its physical form for optimal performance. pH is critical. Some preservatives only work when they're in their undissociated chemical form, which happens in acidic conditions. Sorbic acid is a perfect example. It's only antimicrobial in acidic foods. That's why you often see citric acid and sorbetes used together. The acid creates the optimal pH for the preservative to work effectively. Water activity determines how much available water is in a food product, and this directly affects how additives perform. A humectant like glycerol works by attracting moisture, maintaining softness in confectionery and baked goods. But in layered products, imagine a filled pastry, preservative distribution isn't uniform. It concentrates in the wetter areas, creating uneven protection. Interactions between components are complex and critical. When you fortify foods with iron, that iron can bind with polyphenols and phytates, rendering it less available to our bodies. Food scientists solve this with chelating agents that keep the iron mobile and available for absorption, or they use microencapsulation to isolate the iron. Synergistic effects are when two additives together work better than either alone. Ascorbic acid and tocopherols, for instance, create a powerful antioxidant system. But the reverse can happen. Too much acid can actually deactivate some preservatives, so balance is essential. The journey from factory to consumer shelf matters enormously. Light and oxygen are the enemies of many additives. Anthocyanin pigments fade under light exposure. That's why berry juices should be stored in opaque containers. In oils, oxidation isn't prevented by the antioxidant, it's slowed. Prolonged exposure to oxygen eventually overwhelms even strong antioxidant systems. Modified atmosphere packaging, replacing air with nitrogen or other gases, protects sensitive products. Oxygen scavengers are sachets that actively absorb oxygen inside the package, extending shelf life. Moisture migration is subtle but important. Despite using texture-modifying agents, crackers stored in humid conditions absorb moisture and lose crispness. The balance between texture modifiers and the ambient humidity is a constant negotiation. Manufacturers must anticipate all these factors when formulating products, which is why shelf life testing is so rigorous. This is where food science becomes genuinely innovative. Microencapsulation wraps sensitive ingredients in protective coatings, alginate, starch, or lipid matrices that shield them from heat, acidity, and other stresses. Probiotic bacteria, which are alive but fragile, can be protected so they survive industrial processing and reach consumers still viable. Smart delivery systems are the frontier. Imagine an additive that's dormant during processing, but releases its active form only when pH changes, or when specific enzymes in the digestive tract trigger it. This precision targeting ensures maximum efficacy and minimum side effects. Enzymes are increasingly recognized as both functional ingredients and processing aids. Transglutaminase, for example, cross-links proteins in meat and bakery products, improving texture and shelf stability, often replacing chemical additives entirely, supporting the clean label trend. Sustainability is reshaping the additives industry. Rather than viewing food processing byproducts as waste, innovative companies now see them as valuable raw material. Supercritical CO2 extraction can isolate polyphenols from grape pomace, the solid waste from winemaking, creating potent natural antioxidants. Citrus peels become sources of pectin and flavonoids. Tomato processing waste yields lycopene. Consumer pressure for cleaner labels, fewer artificial ingredients, more transparent sourcing is driving this shift. The trend isn't just marketing, it's substantive. By sourcing additives from food waste using advanced extraction technologies, we simultaneously reduce environmental impact and improve product sustainability credentials. Biotechnology is generating novel functional ingredients with targeted properties. Rather than waiting for nature to provide, we're engineering beneficial bacteria and plants that produce exactly the compounds we need. It's the convergence of sustainability and innovation. The regulatory landscape is evolving. Global harmonization efforts are helping. When the EU, US, and other nations agree on additive safety standards, it streamlines international trade and ensures consumers everywhere receive equivalent protection. But regulations aren't static. New toxicology and metabolomics research continuously updates our understanding. Titanium dioxide, that white pigment used for decades to whiten foods, is now questioned in the EU. This isn't regulatory overreach, it's evidence-based decision-making as science advances. Functional claims face particularly rigorous scrutiny. You can't just say a fiber supports digestive health. Only specific approved fibers can make that claim, and only with specified wording based on robust evidence. Probiotics are even more tightly regulated because efficacy depends on strain, dose, and individual variation. Looking forward, personalized nutrition, driven by nutrigenomics, will likely lead to increasingly specific health claims tailored to genetic profiles, the next frontier in regulation. Consumer behavior is driving real innovation. The clean label revolution isn't just perception, it's genuine demand. Shoppers increasingly scrutinize ingredient lists, preferring foods with recognizable natural components. This has forced the industry to reformulate, sourcing natural alternatives, sometimes from upcycled food waste, to replace traditional synthetic additives. Plant-based foods are a fascinating case study. Creating products that mimic the texture and sensory experience of meat or cheese requires sophisticated use of emulsifiers, stabilizers, and natural colorants. It's technically challenging, but consumer demand has driven rapid innovation. Personalized nutrition is emerging as the ultimate frontier. Imagine a future where your dietary recommendations and the functional ingredients in your foods are tailored to your individual genetics, microbiome profile, and metabolic markers. Your omega-3 dosage optimized for your genetic profile, your prebiotics selected for your specific bacterial communities. It's coming. Let me summarize. Food additives and functional ingredients are far from the scary, unnatural substances they're sometimes portrayed as. They're scientifically evaluated, rigorously regulated, and essential for maintaining safe, nutritious, delicious food in our complex global supply chain. Understanding how processing conditions affect their performance, heat, mechanical stress, pH, water activity, is crucial for food scientists and engineers. Each variable can enhance or undermine additive effectiveness. The industry is moving decisively towards sustainability, transparency, and consumer health alignment. Natural sources, circular economy principles, and clean labels aren't trends. They're the future. Regulations will continue to evolve as toxicology, metabolomics, and other sciences advance. New tools will enable precision and personalization in nutrition. As you move forward in your careers in food science and technology, you'll be part of this transformation, balancing safety, efficacy, sustainability, and consumer expectations. It's a complex, challenging, and genuinely impactful field. Thank you for your attention.